Hi everyone, welcome back to the channel. Today I'll be covering Venn diagrams from the numbers chapter of IGCSE Mathematics. I'll cover some notations, explain a few concepts, and solve two questions. So to begin with, some of the notations you should be aware of is, for example, this cursive E over here. This is a universal set. And universal sets contain our other sets. Universal sets contain all of the elements and all other data that is present in the model. Universal sets also contain our other sets, for example, in this diagram, set A and set B. So on the left-hand side, this circle would represent set A, and this circle would represent set B. And near each set, you would write a letter to represent what set it is. Now, some other notations you should be aware of is, for example, A union B. So this small U shape over here is for union. It means everything in A or everything in B or everything in A and B. So what I mean is, if you would be asked to shade this area on a Venn diagram, it would be this region over here, because not only does it include set A, set B, but also the intersect or the common region. Now moving on, we'd have A intersect B. It's a small N-like shape, and what it means is everything in A and B, as in the common region AB. So if you were be asked to shade that on the diagram, it would be this region over here. Moving on, we also have something known as complement. So complement can apply to any set. So if, for example, we had A complement, that means everything but A. And if you were asked to shade that, that would be all of this over here. You'll realize that I shaded every region except for the regions where A lies, and that includes the intercept of AB because that region also contains A. In some cases, you can also be asked for B complement or A union B whole complement. What that would be is A union B as our first question, but instead of shading inside the two circles, we'd be shading outside the two circles, like in this region. So moving on to our next notation, we will be covering subset. So as you can see in this below diagram, B is fully immersed in A. Or you could also say that B is simply in A. So in that case, B is a subset of A, and it's a C with a dash. Well, not exactly a C, but it looks like a C, and that means subset. So this means all of the elements of B are also elements of A. But not all of the elements of A are elements of B, because in this case, for example, if there were any numbers in this region over here, those would not be included in set B. That's why you cannot say that all of the elements of A are the elements of B. On the left-hand side, here all of the elements are also elements of B because both set A and set B overlap. There is no region where any value or whatever could be where it is not A and B. So in this case, you would say A is a subset of B. Or you can say the reverse, that B is a subset of A because A contains B and B also contains A, and they're perfectly equal to each other. brings me to my point of a proper subset. Now, on the right hand side, coming back to this diagram, as I've said that B is, as I've said that not all of the elements of A are elements of B, therefore you can say that B is a proper subset of A. And that is because A is not equal to B. So when they're equal to each other or they fully contain the other, they can be subsets, but if they're not equal to each other, they can be a subset or a proper subset because they contain each other. Now, one thing to note is that in this notation over here, B is a subset of A is true. But A is not a subset of B because B does not contain A over here. Over here, A contains B. So B is the subset and A is our superset. And supersets are the ones that contain the subset, or basically the bigger sets. So we have our universal set here, set A and set B. Now, if for example our question or given diagram would be something like this, some things you should be aware of are, for example, n bracket b bracket. What this means is the number of elements in set B. In this case, the number of elements would be 1, 2, 3, 4, 5, and 6. It's a total of 6 because it would mean having to count all of the elements present in B, which also means the ones that are in the intersect of AB. And if we were, for example, asked to write the number of elements in A, it would be 2 because we have number 1 and number 3 written in the intersect. There are some cases where, for example, here we have A and here we have B. Let's say A contains a few numbers and B contains nothing. In this case, number of elements of B are 0. So if we were asked to write the elements of B, we put a curly bracket with nothing in between, or we could write it as this, which is basically a 0 with a slash through it. This means that B is an empty set. It means B does not contain any elements. In this top diagram over here, if we were asked to write the elements of B, it would be 1, 3, 2, 4, 6, 8. And these would be a total of 6 elements, as we covered in this portion over here. But if we were asked, for example, for A intersect B, if we had to write all of the elements for that, it would only be 1, 3 because it is the common region of AB. Again, another example, if we were asked to write the number of elements of A in this latter example, it would be 4. And if we had to list all of the elements, it will be the curly bracket and listing everything that is inside it. Another thing you should be wary of is that you can also denote a notation which represents whether an element is actually an element or not of a set. What I mean is, if I wrote 2A, that means 2 is an element of A. If I wrote 2 like this with B, 2 is not an element. of B, which is true. Now you should know that this looking like symbol refers to single elements, but these curly brackets over here represent all of the elements present in that set or part of the set. Now I'd like to cover an example question, and in this question we're told that 28 people were asked what they had for breakfast. 4 had just fruit, 20 had cereal or fruit or both, and 6 had both cereal and fruit. So we have our Venn diagram on the right hand side and we have to fill the data accordingly. Again, the cursive E represents the universal set, F would represent fruit, and C would represent cereal. So by our first statement, 28 people were asked what they had for breakfast. We know that the total would be 28. And we know that 4 had just fruit. So we can easily write 4 in this space because only 4 individuals had only 4 individuals had fruit, and the space where I've written it is the only region which represents only fruits. We also know that 20 had cereal or fruit or both. So that means fruit plus fruit intercepting C plus C, cereal, is equal to 20. That means everything in this region should equal to 20. Then we can further deduce that 6 had both cereal and fruit. That means F intercept C is equal to 6. And now because we know that there are 4 that had just fruit, 6 that had fruit and cereal, and X that have cereal, we'd have a total of 20. We can find out what X is. That would be 20 minus 4 plus 6, which is equal to 10. Now that we know that all of this is 20, there have to be 8 people that had neither of them, because in total 28 were asked, and only 20 of them had either fruits or either cereal or fruits and cereal. So 28 minus 20 would give us the number of people that had neither of them. So that would be 8, and that would be written in the outside space. So the next question I'll be solving is a past paper question. It's from March 19, question paper 42. It's question number 9. So in this question, we're told that the Venn diagram shows two sets, A and B, and the sets contain elements which are alphabets, and we have to use set notation to complete the statements. So in the first statement, it's D dash A. Now we need to check the relationship between lowercase d and A. So you should immediately notice that D is present in set A. Because of that, D is an element of A, and you would denote it with this notation. Now we have two curly brackets containing F and G. The curly brackets represent the elements present in a certain section of the Venn diagram. So the section of the Venn diagram that only contain F and G are the common region between A and B, or where A overlaps with B or B overlaps with A, and that is A intersect B. So that can be represented by A intersect B. Now we have to complete the statement where n bracket dash bracket is equal to 6, and you should know that this represents the number of elements present. So we need to check what region of the Venn diagram contains 6 elements. So for set B, there's 1, 2, 3, 4, 5, 6 elements. So it would be n bracket B bracket is equal to 6 because set B contains 6 elements. Set A, on the other hand, if we had to write the number of elements present, it would be 1, 2, 3, 4, 5. So it is not A. Now in part B, we have to shade C-intercept D complement. So I would normally approach this question by working with what is not related to intercept, and that is D complement. So you should recall that D complement is everything but D. So if you were asked only to shade D complement, that would be this region over here. But our question asks for C-intercept D complement. So in what regions does C overlap with D complement? And that would be this red region over here. So your final answer should only contain these red lines, like so. Now moving on to part C, we're told that 50 students study at least one of these subjects, which are denoted by G, M, and H. That means all 50 students would be represented in G union M union H. Or we can write we can just write it as this, is equal to 50. So a total of 50 students over here definitely have to study one of these subjects. So we would not have any students that would be G union M union H whole complement. That would be 0. Or you could say that it's an empty set. You would write 0 if they asked for the number of elements. Okay, so next we're told that 18 study only mathematics. So it's easy to say that this number over here is 18 because this is the only region where students that only study mathematics would be included. Because as you can see in this region over here, that would mean they study mathematics and geography. But if it was over here, it would be mathematics and history. And if it was here, it would be all 3 subjects, which is incorrect. Now they're telling us 19 study 2 or 3 of these subjects. So the regions where we have 2 or 3 of these subjects would be this place where it's 2 subjects here, 2 subjects here, and 3 subjects over here. So that's 7. So that would basically be 3x plus 7 is equal to 19. And in the third statement, we're told that 23 study geography. So geography should contain a total of 23 students. Now we have to show that x is equal to 4. So we can easily use the statement mentioned over here. And as I've mentioned earlier that 3x plus 7 is equal to 19, we can use that equation to solve for x. That means 3x is equal to 19 minus 7, which is equal to 12. So x is equal to 12 by 3, which is equal to 4. Now we have to complete the Venn diagram. So we know over here that this would be 4, this as well, and this here too. And now we can use this information to calculate the number of students that study only geography. We know the number of students that will study geography in total should be 23. So it should be 4 plus 7 plus 4 plus, let's say, y, which represents this, is equal to 23. So 15 plus y should equal to 23. And so 23 minus 15 should give me y, which is equal to 8. And now we know in total that there were 50 students that had to study at least one of these subjects. So using this equation which I've written over here, this statement, we know first of all that this entire region is 23. This would be 18 plus 4, which is 22. And it should be 23 plus 22 plus y2 should give me 50, because everything within these three circles should equal to 50. So 50 minus 23 plus 22 will give me the value of y2. You can use any other variable like z, but I decided to use y2. So you would get y2 as 5. So 5 would be written in this space here. Now for part 3, we have to use set notation to complete this statement. I'll just erase this surrounding to make it a bit neater. So the notation is G union M union H. Also, as I've mentioned earlier, the complementary of all of that. So there's 0 elements present, therefore it's an empty set. So an empty set can be denoted with this over here, or it can be denoted with the curly arrows with nothing inside. So I could write it as this, or like that. If the question was, for example, N, G union M union H complement, then that would be 0, because that's when they're asking for the number of elements, but that's not what the question is asking for right now. Now we have to find the number of elements for G intercept M union H. Now when you look at the diagram, the region M union H would be over here, and we have to take G intercept of that region, where G overlaps with that region. That would be, wait, this is invisible, this region over here. So we have to write the number of elements present there. So that's 4 plus 4 plus 7, which is 15. Okay, so that is it for this video. I hope it makes sense. If you have any doubts or questions you'd like us to solve, feel free to leave them in the comment section below. If this video helped, consider liking and subscribing, and I'll see you in the next video. Thank you.